Hi everyone, I'm not sick today, so please complete the following. You'll complete this notes packet 3.6, and then you'll complete the 3.6 Wayground number 1. Please ask the sub for the workspace page for that Wayground and show all of your work. Both of these things should be able to be submitted by the end of the period, so please work accordingly. Let's get started. So today we're going to start learning another rule called the chain rule. It's probably the most powerful rule we'll use all year. It makes your life easier when things are to high powers. So let's take a look at that. So this rule is used for something called composite functions. And a composite function is when there's a function inside of another function. Now you can see the rule defined here for you, okay? But let's talk about what this means. So without chain rule, I might be able to give you an example that looks like this. F of x equals 2x plus 1 cubed. And in order to do this question, you would first have to cube 2x plus 1. So what would that look like for us? We would get 2x plus 1 times 2x plus 1 times another 2x plus 1. So we'll take a moment, we'll multiply 2x plus 1 times 2x plus 1. That will give us what? 2x times 2x is a 4x squared, plus a 2x plus a 2x, so plus a 4x, and then plus a 1. And then we have to multiply that again by another 2x plus 1. Now all we're doing right now is simplifying the expression. We're not doing any calculus. So let's keep going. If I wanted to keep going, I would now take each of the terms here and distribute it to the terms over here. So what will that give us? We would have 8x to the third plus 4x squared plus 8x squared plus 4x plus 2x plus 1. Then I would need to combine my like terms. So 8x cubed plus 12x squared plus 6x plus 1. Now none of that is calculus. That was all algebra. So now to get the derivative, I could apply the power rule and get 24x squared plus 24x plus 6. The 1 would go away. Now, you can see how annoying this already was just for a power of 3. But what if I started to make this like a power of 10 or 20? This would be so cumbersome that the problem would be too difficult to complete. So mathematicians found another way that allows you to take functions and see them as an inner function and an outer function. So parallel to this, I'm going to take the exact same function, which is 2x plus 1 cubed, and I'm going to use something called the chain rule. Now, there are two functions here. There's the inner function of 2x plus 1 and the outer function of x cubed, this idea of whatever is inside is being cubed. So with the chain rule, we go right to calculus, and the rule says to do this. You start by applying the power rule just to the outside function. So here's what you do. You take the exponent and you write it in the front. You copy what's inside the parentheses, making no changes, and you subtract 1 from the exponent. That should really feel like power rule to you. I brought down the 3 and I subtracted 1. But this isn't the final answer. To get the final answer, we now multiply by the derivative of the blue part that I have highlighted, because we also have to take into consideration that the inner function was not just x anymore, it's 2x plus 1. So the derivative of 2x plus 1 is times 2. So this part was me doing the derivative of just the cubed, and then this part was me doing the derivative of the inner function. So then I can write my final answer in this format. It'll look like this, 6 times 2x plus 1 squared. Now, if you check your work here and you distribute this out, you actually should get the answer that we wrote over on the other side. So just for checking purposes, let's look. So if I take that, 6 times, this is 4x squared plus 4x plus 1, which we know we did. And if I distribute that, you can see that I would get this answer. So the chain rule allows you to find the derivative of composite functions in a quick and efficient manner. You actually can leave your answer in the expanded out form like I have highlighted in yellow there. So let's apply and do a few examples. We're going to do the odds together, and then you will do the evens on your own, which are parallel questions. Feel free to pause the video as we work. So let's look at the first one. So again, we have an outer function of a cubed, an inner function of x squared plus 1. So when I take the derivative, I multiply by the 3, I copy the parentheses making no changes, and subtract 1 from the exponent. I then multiply by the derivative of the inside. Now the derivative of that blue part is 2x. I then multiply together what's in the front and the back to make it a nice simplified version, and I get 6x times x squared plus 1 squared. And that is your answer using chain rule. If you would prefer to check your answer using the power rule by expanding that out, you can, but it's not needed anymore. Let's look at an example like number 3. Now, right now, this is not set up to do anything. First, I need to rewrite the function by bringing the bottom up to the numerator. When I bring something up to the numerator, I keep what's inside the parentheses exactly the same, and I only change the exponent on the outside to a -2. Now, that is not calculus, that's just the algebra. Now I can apply the chain rule. The chain rule says to multiply by the exponent, copy what's inside, and subtract 1 from the exponent. Then I multiply by the derivative of this inside piece. And the derivative of that inside piece is 6x squared plus 5. Now, for this question, I would like to remove negative exponents from my answer. So here's what I do. I keep the thing in the front and the back together because they both have positive exponents. And I kick the part with the negative exponent down to the denominator, only changing the exponent on the outside. And that's the final answer. It should remind you of the power rule, just a fancy version. What if I have a radical? So if you have a radical, you are going to take what you have and write it as a fractional exponent. So this would be the 1/4 power. I will then multiply by the 1/4 times the 16, which is a 4, copy what's in the parentheses, and subtract 1 from 1/4. That would give me a -3/4. I then have to multiply by the derivative of the inside, which in this case is -1. Again, I can multiply the front and the back together, making a -4. And then I'm going to kick the 4 minus x to the 3/2 to the bottom. This is your final answer. Great. Please try the even examples. When you check your work, just one quick thing, there should be a negative in front of the 180 in number 4. Okay, I hope you paused the video and did those examples. Now we're going to talk about doing ones with the charts. So the chain rule still applies that we do the derivative of the outside function times the derivative of the inside function. So let's look at number 1. In order to find the derivative of w of x, we would write w prime of x. Again, we start with our outside function. We bring that to the front. We don't change anything inside the exponent in the parentheses, and we reduce the exponent by 1. But then I have to multiply by the derivative of the inside function. That is the chain rule. From here, we can now make a substitution. So w prime of 5. So that would be 2 times g of 5 to the first power times g prime of 5. To get these values, you go to the table. So let's take a look. That would be 2 times g of 5 is -3, and g prime of 5 is 0. So in this particular example, I would end up with w prime of 5 is equal to 0. And that's your answer. Now, sometimes you will have to rewrite the functions. If you look at numbers 2 and 4, I have to bring it up to make the exponent negative or write it as a fractional exponent. But there are one other type of problem that you need to be able to do, and that's the true composite function, where k of x equals g of f of x. Now this example, to find the derivative, the outside function is g, the inside function is f. So what we're going to do is the derivative of the outside, making no changes to the inside, and then the derivative of the inner function. Take a moment and try that out. Pause the video. When you are done, please complete and check your work in the answer key section. Have a great day.